I'm so sorry about that. Okay, are we good? I think so. I don't think so. All right, sorry about that. As I was saying, there are a few different characteristics of event-driven architectures that kind of define it. I would say the first one is the different actors that you have in an event-driven system. You really have two. There's producers and consumers. So producers create the events that are in the event-driven system, and consumers consume them. They are acted upon. Another characteristic of event-driven architectures is that they're decoupled. So producers and consumers in the system don't really have any knowledge of each other, and they can be changed, modified independently of one another, and shouldn't impact anything. Additionally, you should be able to add new producers and new consumers to the system without making large changes. Should be able to be done pretty easily. Another characteristic of event-driven architecture is it's all done in real time. So I think you mentioned earlier things happening asynchronously, kind of in the background. That really typifies this, real-time event streaming. Finally, next, I guess we have complete visibility. So every consumer ought to be able to see the events that they care about. So for example, if you have two consumers within the system that are listening for the same event, or have the same filters, they should see all the events that correspond to those filters, rather than events getting split up and some going to one consumer and some going to another. You should see all the events that you care about. And then finally, there's generally two different types of event-driven systems. And they're really based on the push and pull models. So the first would be pub sub, and the second is streaming. So pub sub is where the event architecture keeps track of the subscriptions that exist and push events to the subscribers through things like topics or filtering patterns. And they are temporal, meaning new subscribers generally don't see old events. There isn't an event history. If a subscriber, you attach a new subscriber to a pub sub stream, they're only going to get the new events. They're not going to get the historical ones. And then there's the streaming architecture. So with this design pattern, events are durable and you have a history that's maintained. Additionally, it is a pull model. So you have the consumers that are kind of responsible for making sure that they are consuming the events. And they're generally tasked with keeping track of where in the stream they are, and they have control over that. So they can read events from any part of the stream. One way to think about this is with an iterator. As you're going over a data set, you maintain a position of where you are in the stream. So those are the two models. If you think about AWS, the different services I would correspond to these would be SNS would be an example of pub sub, whereas Kinesis would be an example of streaming. So some of the pros and cons of event-driven architectures, it's not something you would want to use for every type of problem out there. You'd want to make sure that it fits your use case. So the benefits are this decoupling between producers and consumers, the ability to easily add new consumers or new producers without making big changes, the real-time aspect of the data, and the highly scalable and distributed nature of event-driven architectures. Some downsides, some reasons you might want to consider using something else is that it can be difficult to guarantee delivery, and ordered processing and exactly when processing are also difficult challenges. And typically solutions will optimize for one or the other. So you might have some event-driven system that you're using that guarantees ordered processing, but doesn't guarantee only once, meaning you might see the same event multiple times, and vice versa. If you want to learn more about event-driven architecture, there's a couple of books out there that are really good. This Designing Data-Intensive Applications book is awesome. It's mostly focused on data, but there is a chapter on event-driven systems in it that's really good. I would recommend it. And then Flow Architectures is also a really good book if you're interested in this. So EventBridge. Has anyone used EventBridge before? Awesome. Cool. So EventBridge is a service within AWS that is intended to be like the de facto serverless eventing like solution. It's used internally. So AWS uses EventBridge to deliver AWS service events. So for example, you can use EventBridge to listen for, say, someone accessing an S3 bucket in your account. You get those events. So all events that are specific to the AWS services within your account and how they're used, they are automatically sent on EventBridge. Additionally, there's some third-party tooling with EventBridge that allows for you to like create easy connections externally to third-party providers. So for example, if you're using something like New Relic or something else like Dynatrace, it's possible to have that data streamed into your account from that third-party service that you're using via EventBridge. So those are like two pretty like common use cases that come out of the box from AWS. However, you can create custom event buses with EventBridge, and that's where I think the real power comes from. So some of the benefits of EventBridge, it is a pub-sub model, but it has some of the features that you typically like associate with streaming data services. So one aspect of this is replayable events, typically not something that you get with pub-sub, but there's kind of a unique solution within EventBridge that offers this capability in a different way than Kinesis, for example. It has really robust filtering logic. You can create like some pretty dynamic filters using EventBridge, and it supports scheduling as well. So you can create a scheduled like cron job, for example, using EventBridge to send events periodically. It implicitly has schema discovery, and there are native code bindings that you can download for your IDE that have all the information about events that are being sent on the event bus that you care about. That's pretty cool. I haven't had a chance to use it yet, but from what I can see, it seems really awesome. It's like, for example, if you use TypeScript, you can have all the type definitions for all the events that are already known on your event bus. So you don't have to like go and create those type definitions. It's pretty powerful. And finally, and the reason I like it the most is there's direct integration with step functions, which is very powerful. That is not something that SNS or SQS or Kinesis support, directly triggering a step function execution with data from one of those sources. So this is somewhat unique to EventBridge, and hopefully you'll see the value in it as we go through some of the code. So step functions, this is kind of the second piece of the puzzle for what we're going to be talking about today. Has anyone used step functions before? Awesome. Yeah, I know you really like them. So step functions are essentially state machines that you can create with some JSON syntax. There are states that are built into the language that AWS provides. And you can create custom states too. But what this gives you is the ability to create a process that doesn't actually run on anything that you control directly. It's kind of run within the service. So you don't have to actually write any code other than the JSON definition, I guess. It has a lot of like really awesome features. So one thing is it has built-in recovery and retry mechanisms and error handling. We'll talk about that a little bit. This is a pretty powerful feature that it has, and you can do some really interesting things with it. It also has a pretty extensive built-in task functionality, which lets you have fewer lambdas running in your flow. So say you have a process that is designed to handle like new user creation. You might have all of that living like in code somewhere in a service. You could, if you're using AWS services pretty extensively, extract all that logic out into a step function and have much less code that's actually running and rely solely on the uptime of the services in AWS. It has a really awesome logical flow explorer, and just looking at the syntax, it's very easy to understand the different transitions between the states. It can make it a lot easier to grok complicated processes that you might have. For example, we built several state machines that have over like 50 states within them, which is pretty complicated, but you can easily understand it if you're looking at the graph. So it looks very similar to like if you're going to whiteboard it out. And then finally, step functions are different from Lambda in that you can have very long-running executions up to a year. So step functions are really suited for complicated processes that you don't want to stuff inside a single Lambda or expose to like a series of events that are difficult to understand and hard to kind of like group together. In addition to running outside of the parameters of the Lambda execution limits, which I think is like 15 minutes now at the max or something like that. So very powerful. So let's check out some code. Before we move to that though, are there any questions? Yes.
What is it called, step function?
That's a great, I have no idea. I don't know. But you can just think of it like a state machine. A state machine. Yeah. Yeah. I don't know why they chose the name step functions, probably because you can put functions in it and there are steps. I don't know. Sounds good to me. Any other questions? All right. Stop sharing real quick and then can you guys see the text there, or is it's pretty small?
About 50%. Yeah.
Is that good? A little bit more?
Stick it to the
Cool. All right, so we're going to look at some code. What this is a representation of the different resources that we're going to create in AWS in code. So we're using a library called Aws Cdk, which allows you to create AWS infrastructure using a programming language. In this case, we're going to be using TypeScript. If anyone's like not familiar with CDK or has any questions about it, just stop me like in the middle of this. We can talk about it. This is kind of deserving of a talk on its own. But essentially, what we're doing here is we're creating a CloudFormation stack, which is CloudFormation is a service in AWS that allows you to group resources together in a single like unit of infrastructure. In this case, what we're going to be deploying is the event bus. We're going to be deploying a table and a bunch of different state machines, and we're going to play around with some events. So the first thing that we'll create is this event bus, and there's two other things that I've created here that we can talk about briefly. One is called a discoverer, and another is an archive. So a discoverer allows you to get this automated automatic schema discovery that we talked about earlier. You attach it to an event bus, and it listens to the events that are being sent to it, and then generates a schema within the AWS console that you can look at. You can give it filters. I haven't done that here, but you can give it like specific parameters that you want to listen to. For example, you might only want to create schemas automatically for certain events. I just made it for everything. And then the second thing is an archive. So this gives you the ability to replay events and creates like a history of all the events that have been put onto the bus. These are not created by default. You have to actually go into the console and create them, or create them here like I have. And then we have a table. This is just a DynamoDB table, and we'll be using this to store data. The flows that we're going to be looking through are user creation, deletion. I'm just using that as an example, and then we'll dig more into it here. Actually, let me change how I'm doing this. Sorry, I briefly have to log into AWS.
Can you go over how an event bus is different than an EventBridge?
Yeah, so EventBridge is the service, and there's a lot of things that entails. So, for example, EventBridge is how you would like listen to all of these internal AWS events. You can do that through just the EventBridge service. An event bus is like a custom version of that within AWS. Hopefully that makes sense. EventBridge kind of like contains like all the other stuff around it too. Like we talked about the discoverer, the archives. The event bus is like just the stream itself. Yeah. All right. Okay, so I've created here an event bus already. I've named it very well, my event bus, and you can see here that we have an archive. So if we wanted to, this contains 7 days of all the events that have ever been put on this event bus. We could immediately replay all these events right back onto the stream if we wanted to, just by coming here into the console and selecting the archive and clicking replay. I don't believe that Amazon offers you the ability to replay like a subset. I think you can create filters for the archive and only archive certain types of events. But the replay option would replay everything start to finish. So this would be good if, for example, you have like a service outage and for some reason you needed to replay those events because they weren't handled correctly. This would be a great way to do that. And then let's see. There's a schema registry. And when you create a discoverer, it publishes the events that it discovers to this discovered schema registry section. So this is really nice. You can see I have like some test events here that I've created. You can open this and you get a specification of what EventBridge thinks that this event would typically contain. So for example, if it sees like something that's hard coded, for example, I always have sent this event with the source of somewhere. It will just say that in the schema that the source is this particular string. Whereas some of the other properties that are contained within it might have a type, or it might be a reference to a more complicated object. This is I think this is using the JSON schema format. And then there's this option here to download code bindings. I haven't played around with this too much, but what this would give you the ability to do is download like type definitions, for example, for VS Code. And then you don't have to define the create user event. It's already defined for you. All right, so the first thing that we're going to look at is the create user state machine. So I want to create a few different steps. We're going to be using DynamoDB to store users in our system. And I've already created the table here. So some of the steps, we're gonna define those using this library, which is the step functions tasks library. This is the built-in suite of tasks that are provided for you automatically by AWS. You can create tasks with this or with some of the default states that exist. So there's a few of those, and we'll look at those. So the first one that we're going to do is get user. We want to check and see if a user exists before we try to create it. And then create user. So if you look at these definitions, something that might be jumping out at you is this odd syntax here. So there's like this $.detail.email. So what this is referring to is the context of the state machine. So that's one of the cool properties about the state machine, is that through the lifetime of this execution, it maintains a global context object that contains all the data that you might have accumulated throughout the execution of that particular state machine. And you can access it in the different states using this $.dot notation. So for example, when we send an event, when we send the create user event, that event is going to trigger directly this state machine with the content of the event. And the content of the event will have a detail object, which is kind of like the contents of the data that you sent. And there's going to be an email property. So whenever we actually send this event to EventBridge with a JSON object that contains an email property, it's going to be carry over to the execution context of the state machine. And we'll take a look at that in just a second. The first step is getting the user, creating the user, and then we're going to, after we create a user, we're going to put some new events onto the EventBridge. You might have noticed that we're using this built-in state called Dynamo get item and Dynamo put item. Those are like direct integrations with DynamoDB. And then there's this pass object or pass state that we're using. So pass, what this allows you to do is take in input and then return input. So you can do like state manipulation, transform the context into a format that you want, create new properties within the context object, which is what we're doing here. So what we're doing is we're creating a new property within the context with the properties of email and created at. This $sign notation for accessing the context object, there are additional properties that you can access that are relevant to just the execution itself. There's a special context object just for that within the state machine. And to access that, you use the $sign. It's in the AWS documentation, like what's available to you. One of the things which we're using here is the actual time that the execution was started. And we're going to use that to give the user a created at time. And then finally, we're going to use the call AWS service step. And this is where I think state machines really get their power. This particular step is very useful. Essentially, it allows you to call the AWS SDK or the APIs within AWS directly without needing any code. You don't have to do it from a Lambda. You don't have to use any code SDK. You can just do it with this state, similar to like calling the REST API to like perform some AWS operations. So you can literally do any AWS operation that you can do with the code SDK, just natively, like in state machines. In this particular case, what we're doing is we're going to be putting an event back on the event bus that we received an event from.
I had a quick question. Maybe this is out of scope here, but should that do cross count that construct?
That's a good question.
I can look it up.
Yeah, I'm not sure. I would imagine no, but because in that case you'd have to like do a role. You have to assume a role, right? Yeah. So I think that might be difficult. When we get a little bit further down, we'll show like how this is actually working within a state machine. You have to give the state machine permissions to execute the different like actions within the API. I don't know that there's one to make it assume a role. So that.
Yeah, well, I don't want to take it off.
Yeah, no worries. That's a great question.
You can't call Lambda process as a step.
Yes.
That might be.
I think that's different though, because you don't need to assume a role to do that, right?
Yeah, you have to have it set up so that it can. Okay. Yeah, I know you can call another Lambda process.
Okay.
Therefore, you should be able to take off anything.
The real answer to your question is I'm not really sure. So.
Can you make code on the sideboard?
Yes. Yeah.
Fantastic.
Okay. One final thing that I wanted to talk about here. It's not obvious that we're using it because it's kind of obfuscated by the library, but state machines have built-in intrinsic functions that you can call directly from the syntax of the state machine itself. This JSON path.json2string function that we're calling, we're essentially telling the state machine that the data that's at this property, we want to stringify it before we pass it into the detail property of this object. And that's done at the state machine level. It's not done like in code because it has to be performed on the data that's in the context of the state machine.
I'm a little confused by how you use the word state machine. You know, is that a sort of in the AWS context here?
Yes. Yeah.
I don't see the states. You know, clearly.
You will see them shortly.
Okay.
once I deploy this and we start going through it, it'll be more obvious. Right now, what we're talking about is like defining it. This is not like the code that runs. This is the code to deploy the state machine. And then we have this success state finally. So the last thing that we need to do is actually create the state machine and then give it permissions, and then we'll deploy this and run it, and we'll see how everything works. So it's also pretty simple to create a state machine using Aws Cdk. There's this really nice chaining function definition that you can use. It's very easy to read in the code. It's very clear like what's going on. It can get a little bit hairy with larger, more complicated flows, in which case you might want to break them apart and have separate like subflows and then link them together after the fact. But here it's pretty easy to understand like what's going on. We're first going to try and get the user for the email that's being provided in the event. And if the user doesn't exist, then we're going to try and create it and then send the user created event. Otherwise, we're just going to ignore it. We're not going to do anything. And then because we are directly calling AWS services with our state machine, we have to give the state machine permissions to actually do that. So we're doing two things. We're interacting with the DynamoDB table. We're trying to retrieve and save data. And we're also trying to put events on the event bus. So we have to give the state machine permissions to actually do that. Right, and then let's actually give this a shot and make sure I didn't mess anything up. So you can test sending events directly to the event bus, which is very useful for testing, helped me out a lot. The source is not so important. You might use that in your system to like kind of determine where events came from, like which microservice sent what event. And you might want to use different handling states for different sources of the event. For our case, it doesn't really mean anything, so I'm just going to put somewhere. And then detail type. This is the name of the event. So for this, we're going to use create user. Actually, before I do that, I missed one important thing, which is we want to actually link the EventBridge, the event bus to our state machine. So the way that we do that is we create a rule. This essentially creates a subscription on our event bus that says when you get an event that matches this pattern, this criteria, send it to these targets. And in our case, we're going to send it directly to the state machine that we just made. All right, so the format of our event, we just call it create user, and then we pass in email, and then we're going to do test.com. Okay, so we sent it successfully. Now what we want to do is we want to go over to our step function and check it out and make sure everything went okay. So we have our step function here. There's two different modes for step functions. The default is called standard. It gives you an interface that looks like this. You can actually see each individual execution, and you can look deeply into the context throughout the entire process, see every single transition state. There's also express state machines, and those are intended to be for high volume flows, where you don't really need to know things like the history. They're not going to be running for an extended period of time. There's different SLAs and cost metrics associated with express state machines versus standard ones. So there are limitations, but there's like also cost benefits and performance benefits for having your state machine be an express one. So for fast tasks or flows, you probably want them to be in an express machine. Right now, we're just using a standard. So this is the execution. What we were just looking at was kind of a history of all the executions of that particular step function. And then you see there's three different views within the execution. What we're looking at right now is the graph view, and hopefully you can see the states that you were talking about earlier. These are all the different states. So you can see we have all the things that we just talked about, getting the user, checking to see if that user exists or not. And then in this case, the user doesn't exist already. So we created the user, then we formatted an event and sent it to the EventBridge. There's a global execution input and output that you can look at. This tells you the context that your state machine was executed with and what it returned at the end of its execution. This is very useful for debugging, like while you're creating new state machines or trying to fix problems. So you can see here, this is what our step function was triggered with directly from EventBridge. This is all the data that are you could expect to be contained in an EventBridge event. So this is kind of the body of the event that we sent, if you remember. And then here's the output. It kind of like aggregates data as we return it. And if you remember, one of the states, the state where we were looking up the user, we said that we wanted to store the results of that in this user property within the state machine. So if we look at the output, we have now a user property that wasn't there before that contains information about the request that was made with DynamoDB. And then we have this event property, which is what we sent to EventBridge, the data that we sent to EventBridge.
Does it do like a shallow merge or is it deep merge? Do you have the same key?
It overwrites it, I think. So like, for example, if you say, I want this data to live at user, and then like later in your flow, you say, I want this data to live, it's just gonna completely overwrite it. Yeah, that's a good call. You have to be careful about how you're building up your state context. And then this is the definition of that entire state machine that we just built. So that all that code that we wrote, it boils down to this definition. And this is just JSON, as you can see, it's JSON syntax. So some of what the code that we were doing, so I can find it real quick. So if you recall earlier, we were using that JSON to string method that was an intrinsic function. So this is the actual syntax that translates to states.json to string. There's other helper methods that are in this object that you can use in your state machine definition. There's also like some different views that you can use while you're going through an execution. It's really useful for troubleshooting and debugging. So there's a table view that lets you see each state as it was stepped through and what the result of it was. And this is a more granular view of like every single transition within the entire state machine and what the input was for the state and what the output was. So it lets you trace errors like very easily. Yes. Yeah.
In the table view, I'm seeing that does user exist succeeded and then also create user succeeded.
Yeah.
If the user exists, then shouldn't create user not.
So
or oh, the event succeeded, but like the user did contracts.
Right. Yeah. Yeah. The execution of that state was successful. Yeah. So really, what that comes down to is this choice here. And if we look at the choice state one more time, we're checking a property that's in the context object. So .user.item. When you call the DynamoDB get user task, it returns the entire operation to wherever you set the result path to be. But the actual data lives in the .item field. So we're checking to see if that's there. If it's not there, like it wasn't in this execution, like if we go back and look at the output. So we have like all this request metadata about the operation, the get user or the get item DynamoDB operation. But we don't have any actual data. We don't have like an item property. Yes.
Does it show you the total context as you're going through the steps?
Yeah. So if you go to event view, this is kind of what you're looking for, I think. So it gives you the different transitions, and when you go into the entered state, that lets you see the context that's being passed into that particular state. Yep.
Can I reuse steps, and can I make it cited?
Within a single state machine, yes. Yeah. You can't have different branching logic, though, if that makes sense. So it has to be like a single like logical path. So there couldn't be like any ambiguity about like where a step goes, because the definition of it is like strictly defined in the state definition. Like you say, this is the definition, and when this is complete successfully, this is the next transition. So you could do it dynamically that way. For example, like if you had two different flows that ended up in the same place, and then from that point on, they continue in the same direction, then you could do that. Yes.
To me, I love that graph, by the way. It's generated by the interface.
I didn't do it. Yeah.
Anyway,
Yeah.
a state machine, to me, it's a process. So
Uh-huh.
a state machine holds on to state, but it moves between the states in that machine. And this doesn't do that. It doesn't have, you process the user, doesn't change the state of this thing, you just let something flow through.
So I think it might not be like a state machine in the traditional like computer science sense, but essentially the state is like the context of the execution, and that can be manipulated and changed. But I guess you're right. Like it's not a state machine in like the traditional like sense. It's just what they call it.
Confusing, but it's like naming is important.
I agree. Yeah. I'd tell them to change the name, but I'm not sure they would. Cool. All right. So does anyone have any questions about that before we move on? Yes.
Oh, you have more to go. I don't want to. I have tons of questions.
Well, if you have something pertaining to this, then let's talk about it.
Yeah.
Otherwise,
Are you guys using CDK in production?
Yeah.
That's working pretty well.
dude, it's been awesome. I love CDK. Yeah.
Have you ever repeated patterns? Like we do some similar stuff. We've been home rolling a lot of our. I think like those constructs that you showed for DynamoDB and especially that AWS call thing. I wasn't aware of that. We could certainly take advantage of that. But have you guys found like have you ever had to recover from an outage before? Have you actually gone through that process? What's it like in real life? And I don't know if that's too far out. But
That's a great question. Not with state machines. I haven't had to do that personally with state machines. But to give you an idea of some of the eventing architectures that we have used like Kinesis, for example, as like our main event stream. And we've definitely had failures where we had to go back and replay events because they failed for whatever reason. That's pretty typical in highly scaled systems that don't have like every single possible edge case handled, particularly that don't do back pressure very well. That happens a lot. It's definitely a problem that we've run into. Yeah, we have had to recover from failures by replaying events, but not with step functions. I don't think there's any teams using step functions at that scale just yet.
okay.
But yeah. All right.
Can I ask you one more question?
Yeah.
How does this get triggered? What is the trigger for this whole thing to start happening?
So the trigger is an event being put on the event bus. So here we just sent this event. We can resend it actually. So I'm
A request to create use was initiated.
yeah, an event that's sent to the event bus. So in this case, we're mimicking like a producer in our system, creating a create user event. And in turn, because we've set up a rule on this event bus that looks specifically for that event and then sends it to our step function, that's what creates the execution. Yeah.
How do you recover from errors in a certain state?
I'm glad you asked that question. We're going to get to that. Yeah, that's a great question, though. Yeah, so that's one of the main benefits of step functions is the ability to handle and recover from errors. It's much more robust than, say, just doing it within a Lambda. We'll see that. All right, so just for sake of doing it, I've also created a delete user state machine. Actually, before we do this, we can just look at the DynamoDB table, and I'll prove to you that I actually did create the user.
One quick question before we move on.
Yeah.
Around data sensitivity. So this is a user table, maybe in production, like a hash digest or maybe some other sensitive stuff. And I know maybe just for this example, you're just displaying the entire user object. We want to be more sensitive to what fields we put on the event stream.
Almost certainly, yeah. Yeah, I'm just doing this for a demo, but like probably in production, you would likely not have like unencrypted plaintext PI floating around in your event stream. Different companies have like different rules about that. Like we have our own rules at Asurion about what we can and can't have like just floating around in temporal storage. So if it's particularly sensitive, you probably don't want to just have it like living, for example, like in this execution, like someone could just come and just look at the entire data of the state machine, right? Now, if it's an express state machine, you can't do that. So that's one of the benefits. It doesn't store a history; it just maximizes for throughput. So you don't have that problem, but that data is still like in the archive, for example. So. So yes, I did create the user test at test2. So I'm going to create a delete user state machine, and it'll do pretty much the same thing except delete the user. So here you can see we're creating another rule, and this time we're looking for the delete user event. And if I come here and send the same event, but delete user. You should see this delete the user successfully. And then if we come to the table, it's gone.
Is there a construct for like delaying or waiting?
Yeah. Yeah. So there's a wait state, and you can give it like parameters. Typically, it's like a duration. There's lots of constructs that we won't talk about directly. I'm not going to show you everything, but we can pull up the documentation real quick and just look at the different transitions, and I'll briefly explain like how they work, as well as some of the built-in stuff, which is really cool. That's really like the most powerful aspect of state machines, is like all the ways that you can avoid having to write actual like code. Cool. So the last one and the most interesting one is say we want to enhance the flow for creating a user, and once we do create a user, we want to send a welcome email to them. We want to send them an event. Send them an email, welcome them to our service. It's really easy to do that. So for this example, I am going to have to create a Lambda function because I want to show off the error handling that Odette asked about. So okay, so the first thing that we'll do is we'll create a Lambda function. In CDK, you can directly inline code as text into the function definition, which is really cool. It's really good for like quick things. You don't want to write like a lot of like scaffolding around some very simple logic. So this is probably about as much as you would want to do with directly inlining code into a Lambda function. But what we'll do here is we're going to create a few different custom errors in JavaScript, and then we'll show how we can handle them outside of the actual code with the state machine differently. So you can have different behaviors for different types of errors. And these are all custom errors. So this is a real simple handler. Essentially, what we're going to do is we're going to count the number of invocations in the Lambda and have some different behavior in it. And then we'll see that behavior like in the step function. So after we have the Lambda, we can create a Lambda invocation state in the step function. This just points directly to the Lambda and says, when you get to the state, just invoke this Lambda. Right now, we're not going to do anything with the response from it. We're not looking for a response, but we could save a Lambda response to some property in the context object and then do other stuff with it later on in the execution if we wanted to. All right, so there's two helper methods that exists on every single step function state within CDK that let you handle errors and deal with errors in a way that you can recover from them. So the first one is adding a catch. So what this does is it says if this particular state throws an error that matches this definition, we want to catch it and send it somewhere else in the flow. So here, what we're doing is we are looking specifically for this invalid email error. And if we see it, then we want to catch it and then do something else with it. Want to send it to this other state that we're just calling handle invalid email. We're not actually doing anything here, but we're just sending it to a different place. And then retry is another way to deal with errors. So in this particular situation, we want to add a retry for request failed. So like, for example, if us sending the email for whatever that service that we're calling happens to fail, we want to add some recoverability to it. Like what if that service is just like temporarily down or intermittently has errors? We don't want to just cancel the whole execution. We want to see if we can retry it and recover from that error. So we can add an interval, like what amount of time between retries we want to have, and we can add a back-off rate. So basically, the first retry would happen after 2 seconds, and then the next retry would happen after 4 seconds, the multiple of the back-off rate. So you could have a recover back-off exponentially to be as long as you want. You could wait days if you want, if you're using a standard execution. And then you can define max attempts. So we've set that to 3 here, and we're looking specifically for this request failed error, but you could make it more generic. There's helper methods in the task definition that correspond to generic errors that happen within state machines. For example, like service failures, state transition failures. There's different types of errors that can be thrown by the state machine itself. Or you could just say, I want this to handle all errors. Like all errors will be handled by this retry, in which case you could just leave the error object off or error property off. Cool. So then we will create it. And then down here, we're going to add it as another target. So This is going to get triggered by the exact same event. So this kind of shows you how you can have multiple consumers of a particular event that are not disruptive to each other. It's very easy to add them. They don't interact with each other. They don't even know about each other. So now what we're going to do is, let's see. All right, so we can look at this send welcome email. So this execution, this first execution that we sent, the error was thrown, and it's just a generic error. So the error type is called error, and the message is just like something bad happened. If you look at the definition for our machine, we're not actually doing anything with that particular error. So if that error is thrown, that generic error, we're not actually handling it. It's going to result in a execution failure. And the graph view explorer is really cool. It color codes everything based on success or whether it was handled or not. Yeah.
Quick question about that. In this context, is it going to try? Is the Lambda backend going to try and re-execute that Lambda when it grows, or is it just done after it's done the state machine?
Yeah, so that's all up to the definition of the state machine itself. So there are some other services that will retry stuff. So, like for example, EventBridge itself, if it encounters an error when trying to send, like invoke a target, you could have it point directly to a Lambda function and not a step function. In that case, like the service itself will retry, like I think up to a day.
Okay, but because you were in the context of that state machine.
Yes, yeah, it's strictly down to however I've defined it. So if it fails once and I'm not handling it, then it's just going to fail. Okay, so the next execution, well, this also failed, so I can find one. This is all based on whether or not the Lambda has spun down or not. Okay, so I'm going to resend that same event. We should see some different behavior. Okay, so this execution succeeded. And if we look at it, it looks like the error that was thrown here was the invalid email error. So if you remember, we have a handler in the state machine that specifically catches this type of error that is thrown and does something with it. In this case, sends it off to this this event, this state. So if we look at the event view, we can see that this Lambda function failed once. And it failed with this invalid email error. So that's the error type that was thrown. So the next thing that should happen is if we run this again, we should see the request failed error be thrown a couple times. So we'll resend it. And then this should also succeed. This is running, so this is actually running into that retry logic that we created, where we try it a few times. So this is taking some time to execute, but it should succeed. So if we look at the event view, it failed once, and then it waited 2 seconds. And then it failed again, and then it waited 4 seconds, and then the third time it succeeded. So if it had failed again, it would have just failed it, and so that would have been the end of it. But you can see, like, this gives you like a lot of power and control over how you deal with errors within a complex flow. So you don't have to bake it all into code. You can kind of split things out and handle it independently.
Can you show this?
The switch statement? Yeah.
So it's been so, I don't know. Invocations is coming up from where.
This is kind of like a little quirk about lambdas. I'm abusing it a little bit. So the way that lambdas work is you can upload like a function, but in JavaScript you can have like some global variables live outside of the function. So as long as the container that's running the Lambda is like still there, it retains the history of like all the external state outside of the individual function that it's calling. So in this case, I have just like a counter. So each time that the Lambda is invoked, it increments the counter. As soon as this container goes away, that's going to be all erased.
So the step function itself doesn't have.
No, this is just a demonstration of
Any state of that.
no. All the state is just the state that is collected within the execution by the states as they transition. Yeah.
Curious who was in numbers.
Yeah.
Could have returned a value to the step function, right? So then
Yeah.
it wouldn't be a stop it.
I could have done that. Yeah, I didn't think about it. So
You're wrong.
that's right. Cool. That is it. Do we have any questions? Yes. Yeah. It can be if you pass it. So when you execute a step function, you can give it context. So that's kind of how the connection between EventBridge is working. So like as the event comes, that's the context that gets passed to the step function when it executes. So if you wanted to do that, like you wanted to chain step functions directly to one another, which you can do, you can have a step function invoke another step function. You can pass it in context when you do that. Yeah.
As you add more step functions to like a typical application, what's the philosophy for organizing and making sure that you know all of the stuff?
Yeah. I don't know if there's a right way, but the way that I try to think about it is like logical processes. So for example, this one, the logical process that we're thinking about is user creation. Like probably what I would have done is actually put the send welcome email inside that particular state machine. Because it's all kind of like the same process. But you could make them as big or as small as you want. The power of the step function really comes from being able to easily manage complicated flows that you need to have different pathways. That's not so easy to do in code.
In your application, you don't have like one state function.
No.
But it's like change.
Yeah, well, they would handle like different things. Like so, for example, like we wrote a step function on my team not that long ago that does generic data migration. So it's like it's reusable. Like you just plug in like DynamoDB tables and the format that you want the data to be in as you migrate. So we have one for data migration, but there's like step functions for like in the app that I'm working on. We do one for breach monitoring, data breach monitoring. So I work on like the security product. We'd have one for like user scanning, for sending communications to users, logical flows. That's kind of how I would think about it.
How do you write tests?
You don't.
Thank you.
Yeah, that's another great thing is you don't have to write tests for it. So now, with CDK, you can write snapshot tests for infrastructure, and that doesn't like capture like the logical flow of the state machine, but you can use snapshot testing to catch like errors or changes, and that's one way to do it. I would imagine if you wanted to really test this, you'd probably have to write like your own test suite that.
Can you run this locally?
So there's a tool called AWS SAM, which is like serverless application model. I think that's their version of like serverless JS. And they have a tool for it called SAM Local, which the intention of it is to be able to emulate AWS services locally. I believe that there's an integration with CDK, but I haven't looked into it. That would probably be, if I was going to go down that path, that's probably where I would start. Is I would look at SAM Local and see if there's a way to emulate the step functions locally.
Yeah, they put out something I think for DynamoDB. So we haven't tried it.
Yeah.
So back to EventBridge. Does EventBridge have any sort of baked-in support for API gateway WebSockets?
No.
Able to publish and subscribe.
So Aws Cdk, EventBridge. Yeah, I'll send this to you later. So there's this event targets. So it looks like you can send it to API gateway as a target. There's a ton of like really awesome targets for EventBridge that are not like very common. Yeah.
You mentioned early on in the talk controlling either the number of executions like on events, so like only once delivery through the system or in order delivery. What are some ways that you guys have been doing that, or have you run across those use cases in your workflow?
Yeah. So I don't think that we've had to run into this so far with step functions, with EventBridge. I know that they don't guarantee just once delivery, so there could be multiple like event invocations for that particular event. So it is important if you're using EventBridge to make sure that things are idempotent. Like running the same like one event once is not going to result in an error the next time that you run it. You have error handling built into the state machine that accounts for that. Luckily, it's pretty easy to do it. So in terms of ordering, I'm actually not sure about that. That's a really good question. We have run into that before. Generally, if ordering is important, typically like I'll use a queue instead of that. So you can front events being sent into EventBridge with a queue, so you can do the important ordered processing first, and then send everything else into the
When EventBridge, how do you isolate? I mean, how do you design for isolation? If you need to say, Daniel's create email, create user, things going berserk and it's flooding. Flooding the event,
Yeah.
How do you guard yourself from killing everything else?
Yeah. So unfortunately, I don't think with EventBridge there's a way to have per event bus limits. So I believe that's a global like service thing. So for example, like within a single AWS account, you could have like multiple event buses, and say you spam one event bus, it's going to impact the other ones in that account. I'm pretty sure.
But for the EventBridge, it seems to be a global thing, right? That we want to be able to provide messages to anybody who actually just sits in the thing.
Correct. Yeah. So I mean, this is a common problem just within cloud infrastructure generally, right? Like services within AWS are going to have limits. So this is a problem you're going to run into like no matter what within an AWS account. Like you cannot scale infinitely, unfortunately. So that's a great call out though. That's a very common problem that teams run into. I don't think that EventBridge has anything unique built into it that will help with that. You just have to account for it in your architecture. I know like on the Lambda side of things, like you can limit Lambda invocations, you can limit like max concurrency. That's a way to handle like some of that. But it's going to be on a service by service basis for sure.
Cost-wise, how would compare the design? Say you're based on the EventBridge, but you go either with full Lambda or full, step function.
Yeah.
Something equivalent. Are they equivalent in cost too, or?
So step functions. So my answer is it depends, but step functions compare pretty well to Lambda. I wouldn't say the benefit is in cost. The benefit really comes down to not having to write code and having better error handling and flow management for the system that you're building. Trying to bake all of it into a Lambda or have like sequential events that get sent onto like an SNS topic or Kinesis can become quite hairy and difficult to understand. It's complicated. Almost no one groks a system like that. Whereas if you have it in a state machine, it's very easy to see and understand it. The cost question is a good one. Generally speaking, like serverless technologies, for the most part, unless you're at just truly like enormous scale, in which case you need to investigate it and see which technology is going to give you the best cost benefit. They always outperform like other non-serverless services in terms of cost. So if you're running at scale, that's a question you have to look at in a case-by-case basis. It's pretty unique. For example, like the cost model for step functions has to do with like state transitions. So it all comes down to like how you create your state machine. For example, like you want to create it in a way that is cost efficient, probably, if you're running it at scale. Yeah.
So you mentioned that you can be in a state for like multiple days or whatever. What happens if you change that state machine when you're in a state, or does that get like when it's created, it's always going to be that state machine?
That's a good question. I'm pretty sure what happens is you can't change a state execution mid-execution by changing the definition of the state machine.
Okay.
So I think I'm not 100% sure, but I'm fairly certain that what would happen is the execution would run as it was defined previously. Okay. Yeah. Good. See, I was right. Are there any questions on the stream?
My computer died, so maybe check it out. Sorry.
I'm not going to have the history.
Huh?
I'm not going to have the history, am I?
Oh,
Yeah.
Sorry. My kids spilled water on my charger, so luckily it wasn't on the computer.
Here, do you want to use mine real quick? All right. Before we conclude it, unless there's other questions, I want to quickly show some of the other things you can do with step functions that we didn't get a chance to talk about. So there are some other different constructs that we didn't cover. So one of them is called map. So essentially what map lets you do is iterate over a collection within a state machine. So if you had an array of items, you could use the map state to go over each one of them and perform like a task or series of tasks. So we didn't get a chance to cover it, but that's something that you can also do. You can also have states run in parallel. So this is really cool for speeding up things. You don't have to do everything sequentially. For example, you might want to hit like a bunch of different systems to get data. And then once you have all the data, then do something. And you can maybe do all those things in parallel instead of having to wait one after the other. And then we talked about wait, which I think Will asked about. And then these are some of the operations that are kind of supported natively by state machines. One cool one that we didn't get a chance to talk about is invoking API gateway directly from your state machine. That's pretty cool. I haven't played around with it too much, but there's another one. I think it's I can't remember which one of these it is, but essentially it lets you poll like an ECS cluster. Essentially, like you send some data to a running service, and then you wait for a response. You can poll to get a response back. So I haven't played around with that one too much, but
So that Lambda invoke construct right there, that's the one that basically captures that execution and just keeps it inside of the.
yeah,
Basically takes it away from the Lambda backend, sort of, like if it fails.
yeah. So what we did was we created a Lambda function using this function object, and then the Lambda invoke just says in this state I want to invoke a Lambda function. We just defined it to be that Lambda that we just created. It could be an existing Lambda that
You just pass an ARN from another.
Yeah.
Lambda.
exactly. Yeah. Well, yeah, essentially. Yeah. What this boils down to is like in the state machine definition, it's the resource is an ARN.
That's awesome. We've got some old stuff, funny to call it old, but using the 5 watch events before EventBridge came around, and so like we've run into issues with the Lambda back and retry stuff, and we have to get like direct to DLQ or whatever, just try and
Yeah.
not have to.
I'm glad you brought that up. So I mentioned before, like error handling at the EventBridge level. So there's a retry mechanism built into it. I think it'll try to invoke a target for like up to 24 hours. If that fails, there is a DLQ process similar to Lambda and like SNS. So if it fails, you can configure this to write that event off to a DLQ to be handled later, or you can use the event replay from the archive.
What do you design this if you needed like a response? Say, great user needs to return user ID.
So typically, like how you would handle that in an event-driven system is you would produce an event that has the information that you needed. So, for example, like we are creating a user-created event that if we made a UUID, it would be there.
Or like a part of the system wouldn't wait for a specific event with a specific.
Yes.
specific user.
Yes.
If it was like more. Like from a browser request to a Lambda, then invoking this action. Create that event, maybe have a web socket.
Okay. Yeah.
Consumer listening to that event, go back to the browser.
Yeah. So if you're talking about like the client, like from the client side, so it's not really like a you could do that by using WebSockets, like Will's talking about, which we have done that before with like different things. WebSockets are awesome in being able to get events from like a backend system. So that's a different talk.
I think it's a good question because that makes it sound a little more like a sort of backend tool. Building itself, not for interacting teams.
Yeah, for sure. Yeah, like what WebSockets are like just a client way a way to consume event-driven architectures from a client perspective. So
something when you started out that for long running processes, this might be an advantage.
Oh yeah.
How do you figure that?
So typically, like in AWS, when people think of like creating a serverless event system, the workhorse of that would be Lambda probably. You would write code in a Lambda that would respond to an event from SNS or SQS or Kinesis. So the problem with that is that Lambda has execution limits. So for example, a Lambda function can only be running for up to 15 minutes. I think that's the maximum. I can't remember. So if you need for something to run longer than 15 minutes, you have to write some funny logic inside your Lambda that checks the execution time and invokes another Lambda to continue the execution. So it's a little bit hacky. Whereas you can very easily do this with a step function without having to do all that.
But if you did and you didn't actually receive any messages, you would proceed to twiddle your expensive phones.
I'm sorry?
I mean, isn't this spun up on demand when you need it? So if you and take it down if it doesn't see traffic, how does that compute management?
Well, the step function, I'm sure there's a server running somewhere, but there's no like container that you really know about. It's just a service that's running. And it's not like the execution of the step function is not governed by that. It's governed by the limits set by the service. So in this case, for standard step function execution, AWS says the longest you can have it running is a year. So it just runs. I don't know the specific internals of like how AWS systems work or how they deal with that, but
You pay for steps inside of the transitions.
correct. Yeah, you pay for state transitions and the time spent executing that state. That's the drivers of the cost. So the time that you spend waiting, if you're not doing anything, then you're not getting charged for it.
Because you may have it like the delay construct you had on the docs there. If you went from one step and delayed for 3 days, you're not paying for that 3 days, you're paying for the transition to the delay.
Yeah.
Or whatever that minimal cost is. And
Yes,
then after
actually.
3 days, the next step function would run.
Let's look at that real quick just so you can get an example of what we're talking about here. So you can see this started time, and I think there's like an execution time in here somewhere. But essentially what you'd be charged for is the time difference between step function started and step function scheduled, I believe. So the actual execution time, rather than like the time spent waiting between executions. Any other questions? Thank you for coming to my TED Talk. Appreciate it. Did we have any questions on the stream?